Welcome to the WickerShire project, off-grid.
I think I'm overthinking everything.
It's movie night down at John's. It's Friday. Movie night again on Saturday. We're doing a preview to see how the system works. Bella's with me, and there's Nathan. You excited to go, buddy? All right, let's get out of here. Enjoy the show. As we're progressing and getting things done here at the Shire, I'm starting to think about my electrical build. Now, in the manual, it says in an RV application, to connect the ground wires together. This gives an isolated closed loop for the grounding system. It's just the way it works. I have a mains AC panel. And the way that works is my inverter has two hot legs, 120, and a neutral. Inside the Ames inverter, it says you cannot bond the ground with the neutral. Just can't do that, or else you'll damage the unit. So I got to really look into the product and figure out how to wire this all in. It's driving me nuts, and I think I'm overthinking everything. What I need to do is isolate each device, every single component, and how they wire up to each other. Now the AC side I understand, as the hot leg comes in 120 and the other hot leg comes in 120. It's 120, 120. Any devices will use a double pole breaker, which means the 120 on this side and the 120 on this side, when you clip a double pole breaker, each of those poles inside are now energized with 120 and 120, giving us 240 output. I understand how that works. In that style of application of 240, there is no neutral. It's just not how 240 works. You don't get a neutral. What you do get is an isolated ground. So the outside metal casing, if ever one of those 120 or both of them ever pop out and touch the casing, you now have a short. And that could lead to fire. That's where the ground comes in. As the ground wire goes onto the casing, if one of those hot wires touches the casing, the electricity flows through onto the ground, returns, and goes down into the grounding rod. That's simple. AC application is simple. I get it. In a 120 situation, you have a hot leg, 120, you have a neutral for return, and then you have the case ground, separate, so 3 wires. You got power going out, power coming in. And in case of a short, where one of these pops off, the ground takes care of the return and sends it into the ground or back into the grid. But we're off grid, so yeah, another complication of being off grid. I don't have the grid to send power back to, which is the way returns normally happen. And there is an isolated ground in every single home. It's just the way it works, I guess. My problem here lies within my Ames 6,000 watt pure sine low frequency inverter. Say that 10 times fast.
My problem here lies within my Ames 6,000 watt pure sine low frequency inverter. My problem here lies within my Ames 6,000 watt pure sine low frequency inverter.
It says in the inverter, and this is why I'm so confused, is that you're not allowed to cross the ground and neutral. So if I look at the Ames inverter, it has a ground, 2 ground wires that connect together. That's for an RV application. It's a closed loop. Is that bonded? I'm not sure. Get it? I'm losing my mind here. On the Ames inverter, it has a ground, right? Just a pure ground. It has a hot leg 1, hot leg 2. That comes in from your power source. This is to energize the 120 volt, aka 240 application. On the AC out, check this out. On the AC out, it does have a hot leg out, and a neutral. There is no ground. So now I got to figure out how this works, because on the Ames case itself, on that inverter, there is a lug that is a grounding lug. Therefore, that is my ground out to the grounding rod. Here's the backside of the DC on the inverter. You have your negative, you have your positive. Down there is the grounding terminal that goes out to a rod. But wait, there's more. What do I do with the ground terminal? Once I think what I have to do is I have the generator, and I got to go look at that to see how the neutral and the ground is bonded out there. Ugh. This is my 240 50 amp RV plug that goes to my inverter to charge my battery on the bad days. It's grounded to the chassis. So this is a bonded ground, or a bonded neutral. Ames inverter, let's go back to that. So it has a closed loop ground, it has a ground, a hot and a hot coming in. I want to say if you have batteries being charged up by an RV or an RV's alternator, that the ground loop stays connected, that ground, those two grounding wires connect, and it's a floating ground. These are my RV grounds, here and here for RV style. I believe because I have an outside source, I have a generator, the grounding wires separate. Because you have a ground wire from the generator coming in. You guys remember outside on the generator, it has a ground wire coming in. So this ground leads out to the ground of the generator. And so what this ground does specifically is handles the power outside, whether or not what that may be. And that happens to be the generator. So now we have a ground situation. If there's a fault, the ground goes back to the generator. This is why I have to go look at the generator to see how it's bonded or unbonded. Confused yet? People who do electrical work, feel free to mush your brains out and give me some info. I'm not holding you to it. What you're doing is you're taking my DIY sense of how closed circuitry works, and you're expanding it in DC and AC applications. I understand the basics. I know how it all works. But when you throw a monkey wrench in, such as an inverter as this, and it has a casing ground that goes out to the ground rod, but then it has a ground on the top with a ground that connects together. You don't do two at the same time. I have to call the Ames manufacturer and say, I have my AC panel with its ground, and that goes to the grounding rod. On your inverter, I have the case ground, which I believe also goes to the grounding rod. Now that I have a generator coming in, or AC power source coming in, what do I do with the ground lug in and the ground connector? Do I keep them together or separate them? I believe because we have power coming in, they need to be separated, and the grounding wire needs to be put into the input. It's not an easy scenario, and it may seem confusing. There's a whole lot of powers coming in and grounding in neutrals, and then has to go from DC out over to the AC side, which has its own normal utility style to code build of how you would do that. In some scenarios inside the AC terminal, that the ground is also bonded over to the neutral. What threw my mind into a blender was, in the manual, it says never to cross-connect the ground to neutral. But that's an isolated scenario. You can't think like that. You're putting too much information into the soup bowl. My AC side can have a neutral to ground, and the ground goes to the ground rod. That's a separate issue as those wires come in. Those two hot legs and the neutral comes in. The inverter is an isolated situation in itself on the backside. I'm going to call the company and figure out what to do now that I have an actual ground going to a ground rod. So I think those grounding wires in the back of the inverter need to be split apart. And I'm
Done.
I think the ground that in the back where it says ground hot hot, the ground is only for the application coming in, the power coming in, that has to go back to the source. And that source would be the generator. So I think I'm figuring this out slowly. The generator has a bonded ground outside. This ground goes out there, hot leg 1, hot leg 2 coming in. So you got 120 volt, 120 volt, and we have a neutral wire. Why is there a neutral wire? Because at any point in time, this 120 or this 120 in 120 application needs a return. And that's what the neutral does. It sends the power back. In a 240 application, this hot and this hot are connected together in the device. And there is no neutral. But that device should have a ground coming back to ground the unit out in case of a short. AC panel box has a ground, a neutral, 120 and 120. So I know that the ground inside this case, in case there's a short anywhere, goes out to the grounding rod. So my generator runs to my Ames inverter. It converts AC power to DC power. Runs over to my 48 volt DC lithium 15 kilowatt DIY battery power wall. As you can see, it has 4 connections, and in those 4 connections is 120, 120, ground, and a neutral that is not used in application. Why is that? My inverter has a looped ground, it has a separate ground, and it has a hot and a hot coming in, a 120 and a 120. The inverter then converts AC to DC and charges up the battery. The inverter is also an inverter generator, so it will invert the DC as well as the AC coming in. Depending on how you have the dip switches connected, you'll use either generator or you will use battery. Can it charge the battery while you're using AC? Absolutely. It puts the load on the generator, the power coming in, if there's power coming in. If there's no power coming in, it just uses the battery. My Ames inverter has a lug for a ground rod. My AC mains panel has a bar, grounding bar, that goes out to the ground. It also has a neutral bar for 120 application. Anything we use, such as a hair dryer, lights, computer, all go to the neutral. From the Ames inverter, we have 2 hot legs going out. We have a 120 volt here, 120 volt there. So that takes care of either 120 or 120 connections, depending on where you put the breaker, what side, and also with a dual pole breaker, it will combine and use each hot leg of these to send out 240 volt power. My big concern with this Ames inverter, which got me so confused, is never, ever, ever connect the ground to the neutral. That application has me concerned, but I think I'm overthinking this. My main focus is, how do I use the ground? Well, in an RV style, the ground is connected to the chassis. If that is the case, you would take the ground and apply it to the chassis. And I think what you do is you connect these 2 green wires together and create a loop. My other concern is this. As this is an isolated power source, and this is an isolated inverter, and the generator only comes on when we need to power up and charge said battery through the inverter. I know for a fact that the inverter must be grounded. I know for a fact that the AC must be grounded. My question is to you electricians out there, do I bond the ground to neutral bus bar in this application? What I have here in my application is a isolated ground, hot leg 1, hot leg 2 input. Then that's AC from the generator. Ground, hot leg, AC in. AC out is going to be hot leg, and a neutral. If you're completely confused as I am about this video, please give us a like. Leave me a comment down below, and I'll get back to you within 48 hours. And yeah, we'll catch you on the next one. So bye for now. So now we know that the generator is grounded to the chassis. That's a bonded ground. Bonded ground, bonded neutral, bonded ground, neutral to ground bond. And I think I'm going to ask Nathan what happened to this, because this has a screw and a rubber protector, and it's completely unscrewed. I don't know, Pip, who's got a bigger beard?
Beard.
You or me? I don't need to use the ground in the back, ground to the ground system, the ground to the ground to the ground, because it has a case ground. But I do know it's grounded to the chassis, whether that's a neutral ground or a grounding bar. I don't know. It's a mess. Any electricians out there want to take a visit to the Shire and help me wire this out?